Hello friends, welcome back to Relief Tutorials. Now we will do exercise, but before that see textbook example 10. Show that 5 minus root 3 is irrational. See, I have told you one fact, this is rational number, this is irrational number. So difference or sum of rational and irrational number is always rational. Clear? Now we have to prove this. So let us assume that 5 minus root 3 is rational. Okay. So therefore 5 minus root 3 is equals to a upon b, where b is not equal to 0 and we can say a and b are co-primes. Clear? So now I can say root 3 will go here. See, from this you have to choose irrational number always. So what we can do, root 3 goes here. So I can say root 3 is equals to 5 minus a upon b. So therefore root 3 is equals to, here you will get b, here 5b minus a. Okay. Now since a and b are integers, I have told you a upon b, a comma b belongs to z, b is not equal to 0 and a and b are co-primes. Now this a and b are integers, so 5b is also integers, 5b minus a is also integer, b is integer. So since a and b are integer, okay, we get 5b minus a upon b is a rational. Clear? See, a and b are integer, 5b is integer, 5b minus a is also integer and b is integer, so p upon q, so it is rational. Okay, so this is rational, so we can say root 3 is also rational. Okay friends, if this is rational, both are equal. If this is rational, this is also rational, but this contradicts the fact that root 3 is irrational. We know that root 3 is irrational, but here we got that it is a rational, so it contradicts the fact that root 3 is irrational. So we can say this contradiction has arisen. This contradiction has arisen because of our assumption. What was our assumption? Because of our assumption that 5 minus root 3 is rational. We have supposed that 5 minus root 3 is rational. So whatever the contradiction has arisen, that is because of our assumption that 5 minus root 3 is rational. So therefore we can say 5 minus root 3 is irrational. Have you got it friends? Very simple, as we have done. Root 2 is rational, root 5 is rational. Now we will do example 11. What is that? Show that 3 root 2 is irrational. See, 3 is rational, root 2 is rational. Product of rational and irrational is always irrational. I have explained you. This you have to show. Now what we'll do? Same thing. Let us assume that 3 root 2 is a rational. Then we will say our assumption is wrong. So therefore 3 root 2 is equals to a by b, where a comma b belongs to z, b is not equal to 0 and a and b are co-primes. So therefore from his, which is rational? Irrational, root 2. So we'll find the value of root 2 is equals to a by 3 multiplication. When it goes here, division, 3b. Okay. Now since 3a and b are integers, a upon 3b is a rational. You know, see, a is integer, b is integer, 3 is integer. So 3 into b is also a integer. So a upon 3b is a rational. So this is rational. So root 2 is also a rational. Clear? So we can say root 2 is a rational. But same thing, this contradicts the fact. But this contradicts the fact that root 2 is irrational. And you know that this contradiction has arisen. Same thing we have to write. This contradiction has arisen because of our. This contradiction has arisen. Why? Because of our incorrect assumption. Incorrect assumption that 3 root 2 is rational. So therefore 3 root 2 is irrational. So in this manner you can do each and every problem. So it is quite easy. Now we will do your textbook problems. See exercise 1.3 textbook question number 2. What you have to prove? You have to prove that 3 plus 2 root 5 is irrational. So you know how to prove. Same. Let us assume that 3 plus 2 root 5 is a rational. Okay, same step. So therefore 3 plus 2 root 5 is equals to a by b, where a comma b belongs to z, b is not equal to 0, and a and b are co-primes. Same thing you have to suppose, same step. So therefore now you will find the value of this. So 2 root 5 is equals to a upon b minus 3. This 3 I am sending on this side. You have to just keep here irrational number, that is root 5. Clear? So what you will get, 2 root 5 is equals to, here LCM is b, here a minus 3b. Okay. So therefore what you will get here now, root 5 is equals to a minus 3b upon 2b. Just you have to find the value of irrational number. Now since a, b, 2 and 3, 2, 3, a and b are integers. They are integers. So we can say a minus 3b is also integer, 2b is also integer. So p upon q form we can say is a rational. So this is a rational. So you can say root 5 is also irrational. But you know root 5 is irrational. So this contradicts the fact that root 5 is irrational. We know that root 5 is irrational, and this contradiction has arisen. How? Because of our incorrect assumption that 3 plus 2 root 5 is rational. Clear? So therefore you can say 3 plus 2 root 5 is irrational. Same step, same process. Clear? Now we will do question number 3, textbook 1. Show that 1 upon root 2 is irrational. You have to show that 1 upon root 2 is irrational. Clear? So now let us assume that, see, this is quotient of rational and irrational. Quotient of rational and irrational is always irrational. So let us assume that 1 upon root 2 is rational. So therefore 1 upon root 2 is equals to a by b, where a comma b belongs to z, b is not equal to 0, a and b are co-primes. Now from this you will find root 2. So cross multiplication, root 2a is equals to b. Clear? So now root 2 is equals to b by a. Root 2 is equals to b by a. We got root 2 is equals to b by a. So now here you can say okay, b and a are integer. Now we can say since a and b are integers, b by a is rational. So root 2 is irrational. Clear? But this contradicts the fact that root 2 is irrational. Same thing. So this contradiction has arisen. So this contradiction has arisen because of our incorrect assumption. That 1 upon root 2 is irrational. So therefore we can say 1 upon root 2 is irrational. Same fact you have to explain, that's all. Now same thing now, same question 3. Now we'll do 2. That is show 7 root 5 is irrational. 7 is irrational, root 5 is irrational, product of rational and irrational is always irrational. So this you have to explain. Then we can say, let us assume that 7 root 5 is irrational. So therefore 7 root 5 is equals to a by b, where a comma b belongs to z, b is not equal to 0 and a and b are co-primes. Now here which is irrational? Root 5. So you write root 5 is equals to a upon 7b. Now since 7a and b are integers, a upon 7b is rational. Okay, so root 5 is rational. If this is rational, this is also rational, they are equal. But you know root 5 is irrational, but this contradicts the fact that root 5 is irrational. So this contradiction arises. This contradiction has arisen, this contradiction has arisen because of our incorrect assumption. What was our assumption? That 7 root 5 is rational. So therefore you can conclude that 7 root 5 is irrational. Have you got it, friends? And the last problem we are going to do is question number 3. What is that? We have to show that 6 plus root 2 is irrational. Clear? So now let us assume same step. Let us assume that 6 plus root 2 is a rational. So therefore 6 plus root 2 is a rational, so it can be expressed in the form a by b, where you know a comma b belongs to integer, b is not equal to 0, and a and b are co-primes. Now you have to select here which is irrational, root 2. So now root 2 is equals to a by b minus 6. So root 2, here LCM will be b, so a minus 6b. Clear? So now a is integer, b is integer, 6b is integer. So difference of two integer is an integer upon b. b is also integer. So therefore we can say here, since 6a and b are integers, a minus 6b upon b is a rational. Why? See, this 6 is integer, b is integer, 6b is integer, a is integer, and you know that in lower standard we have learned difference of two integer is always an integer. So numerator is integer, b is integer, denominator is integer, it is not equal to 0. Here we have seen b is not equal to 0. So numerator upon denominator is a rational number. So root 2 is a rational. But you know that root 2 is irrational. So we can say, but this contradicts the fact that root 2 is irrational. Clear? So this contradiction has arisen. Why? Because of our incorrect assumption that 6 plus root 2 is rational. So therefore our assumption is wrong. So 6 plus root 2 is irrational. So we have completed your exercise. We have done few examples. Clear? So now this portion has been completed. So this portion has been completed. So we have completed your exercise 1.3. I hope you have enjoyed the lecture. This particular lecture was very important because one of the question will be asked. So please try to understand the theories and just you try to solve each and every problem. You note it down in your classwork, go through it, make it clear. If you have any doubts or any ambiguity, please feel free to call me. So you understand properly and you try to do all this problem by your own. It is very important. So please stay safe, stay happy. Thank you very much.